Start the YouTube stream now?
I think that could be okay.
Done.
So is our June Bake High program will commence in a couple of minutes. We have a fantastic speaker from University of Colorado, although he seems to have a different university behind him in that picture. Clayton, what is that picture?
That's St. Louis University. That's the host of the workshop I'm attending this week.
Ah. And what is the workshop?
It's on embodied cognition and HCI and inclusive technology.
Wow.
Jenna Gorlovich of mechanical engineering at St. Louis U is the host, and my colleague Emily Moore is one of the organizers, and Dor Abramson from Berkeley is one of the organizers. So it's been a fun event. And St. Louis University, which I'd never been, it's got a gorgeous campus.
Uh-huh. Oh, great. Great.
And I'm told it's the oldest university west of the Mississippi.
Wow. It kind of, I mean, that's interesting given that it's right next to the Mississippi.
Yeah.
So I've never been to, I've only heard of that university. I've been to St. Louis. It's a very complicated place.
Yeah.
And so you're there for several days, and so it's a little later where you are.
Mhm.
Sorry about that. So we now have 10 people here. And, you know, it's almost like we want to have at least a baker's dozen to get started, don't you think?
Up to you. You can wait another couple minutes and see how many more come in.
Yeah. Yeah, we'll wait till at 7:31 or 2 to start the program. Well, welcome everybody to the June Bake High monthly program. Tonight we have Clayton Lewis from the University of Colorado giving a talk about prospects for artificial personal assistants. And in his case, there's a lot of personal assistants really have a lot to do with people with disabilities. I'll talk a little bit more about that in a little bit. I'm Ted Selker, and tonight is the night that we have Bake High elections every year. And so tonight we have only nominations, one nomination each for co-chair and chair, Edwin Lee and Ted Selker. Treasurer, we have an acting treasurer, Steve Williams, but we are looking for how we're going to fill that position for Bake High in the next month. And we are interested in any possible nominations for any of these before we hold an election tonight. So is there anybody that wants to make a nomination? Please, you know, raise your hand or whatever you'd like to do.
And self-nominations are legal.
Okay, I don't see any starting, although I'm going to be open to them throughout this process. And what I want to say is that at this point, really what we need to do is just a raise of hands for supporting this ticket. It seems that Edwin Lee and Ted Selker are the current continuing chair and co-chair. We have many other opportunities to support the Bake High, and I'll talk about that as soon as we're done with this step. So could some people maybe raise their hands that they are in support of this this. Where is that?
I think
Don't see hands.
under participants, you should be able to see people whose hands are raised.
And participants can see reactions is where they can raise their hand or give a thumbs up.
Okay, so I have one raised hand, two.
And then it goes away if you don't
yeah,
do something, right?
Okay, and we have, okay, so we have some raised hands. So I will just count that as a positive. We will try to, maybe I will even raise my hand, although I feel funny about that. I guess I get to, but don't feel like I should. Anyway, okay, I think that we are just gonna not belabor this, and we're just gonna go on to the rest of the program now. So thank you, everybody, for your support. BayChi is an ACM organization. It is associated with SIGCHI, and we have been holding a monthly event every month since 1989. Often when there was in person, it was at Xerox Park in Palo Alto. Now it's been on Zoom for a while, as everything else has. And Nancy Frischberg's been part of this effort from most of the time. And she's served many roles. She's currently also been responsible for any Facebook or Twitter or any other social media you saw about this talk. And she is also responsible for bringing every other meeting speaker here. I'm running it every even month. She's running it every odd month. I'm talking about this so much because Nancy has indicated that she's really looking for people that she can mentor that will take over some of these responsibilities. And then there are people that can help. Steve Williams, who's been tireless at making the website work, technology work, everything from billing to our wonderful consultant database, and so on. And he too can have, you could help him do that job. And web content, Birds of a Feather Chair, on this screen, you see Edwin Lee, co-chair. He's also running two things. He runs a dinner right before the meeting, and he also runs a Birds of a Feather for people to talk about and think about jobs and job changes in the user interface area. And it's on the 4th, is it the 4th Tuesday of the month, Edwin? So there's many
That's
other
right.
things. Yeah, there's many more other things you can do. The thing that really is a simple way to get involved is coming to the steering committee. That's really just where we talk about how we run BayChi, and that's on the first Thursday of the month. It's announced on the calendar. So consider doing that. All right. So enough of this. The most exciting part is yet to come, and that is that this week I want to introduce Clayton Lewis, who's going to be giving our program this evening, and he is a fellow at the Institute of Cognitive Science at the University of Colorado Boulder. He has been there for, I don't know, 35 years. I came to IBM Research as a young punk to work on human-computer interaction about a month after he left. And everybody was in despair. They were very, very sad. He built what it was called the User Interface Institute there, and Jack Carroll took it over. Jack Carroll's a fantastic man who's written several books on human-computer interaction, but we all missed Clayton. And now and then Clayton would come back and visit from University of Colorado. I also went to visit him at University of Colorado, where his colleague Gerhard Fischer was working on intelligent tutoring, as I was. And Clayton was working on many, many things, but most of all, over the years, I've seen him work a lot on a user interface for disabilities. And he's run several organizations. He's gone off and worked at companies on sabbaticals. He's worked at, I think it's the National Science Foundation when he took sabbaticals to work on funding of these things. And anyway, he's been a tireless and a worker, but also he's been inspirational to many, many people, including, as I said, the user interface community, which Nancy also was part of at one point. And he also has been chair of the Department of Computer Science at University of Colorado Boulder. And anyway, many wonderful things about Clayton. But the most important thing isn't any of that. What is the most important thing is the way that he can speak about interesting ideas and inspire us. And so, without any more ado, I want to welcome Clayton to give his talk this evening.
So this is not just the usual fumbling for these handoffs, but we were supposed to wait a couple of beats, but the fumbling is now ample to take care of that. So let me get rid of this window and hope to find the one that actually has the talk in it. Let's see here. Okay, there we go. Okay, great. Well, thank you, Ted, and thanks to Nancy and Stacy for the invitation and the arrangements for this. I've had the privilege over many years of attending and sometimes otherwise participating in BayChi events. It's a legendary organization, and I'm really honored to have a chance to meet with all of you. I'll also say that talking about artificial intelligence to a group in the Bay Area gives me a distinct Coles to Newcastle feel. I don't pretend that I know more about what we're talking about than many of you do, but I have to give the talk. So let's keep it light and see where it gets us. So here's where we're going. I want to talk about what I'm calling language model-based AI. You'll recognize what that is when we get into it. And then I want to look at a particular use case that comes from the disability personal assistant space, and talk a little bit about the general character of this technology and what I think is especially interesting about it. But then there are some limitations to it, of course, and then finally some discussion. And the plan is to have ample time to talk about all this. So I'd love to hear what you all think about it, including the bitter complaints you may have about what I have to say about it. So what is it? Well, the examples here that I'll be talking about are the, by now probably familiar to many people, GPT-3 and Codex systems. And what these systems do is to create predictive models of text in the case of GPT-3, that is English language text, or code in the case of Codex. So how does this work? Well, you start with an enormous corpus of whatever it is that you're interested in. So enormous means in the case of GPT-3 that all of Wikipedia is a small part of the corpus. So the corpus also contains the complete text of 250,000 books. So this is really a lot of text. So you start with that, and then you have a large, complicated neural network, and you just train it laboriously, not laboriously for the digital demons, but not for any human being. So the digital demons choose a sequence of 1,000 items from the corpus somewhere and ask GPT-3, what do you think comes next? What's the next item? And GPT-3, of course, initially, whoops, what happened? This is really strange. Suddenly my Chrome window completely went away. Let's see if we can restore it. Well, okay. Thought that's where we were. Sorry about this. Okay. So of course, initially GPT-3 has no idea at all what the next item is. How would it know? So it makes a guess, and it's then told what it should have guessed, and it adjusts its weights as the way of these things. And you do this a gajillion times, and remarkably, the thing becomes able to make good predictions. Now, I'll just note that there's no way it can actually memorize this vast corpus. So what it's forced to do to make good predictions is to find regularities in the way it can encode particular items in the corpus and sequences thereof, so that it can have a hope of predicting what comes next. And this has the really crucial side effect is that it also acquires the ability to make predictions about things that it's never seen before. Okay, so that's a key part of it. It wouldn't be very interesting if all it could do was just tell you if you were asking about something that it had seen. But what's interesting is that you can ask it about things that it's never seen. You'll see examples of that. Okay, so the Codex system that's going to be the focus for a lot of this does this with code. And it turns out that this relatively simple scheme that I described conceptually is actually able to do a form of automatic programming. So how does that work? Oh, I should have said, once one of these systems has been trained, then you declare the end of training and you say it's learned everything it's ever going to learn. And thereafter, you use it in a very simple way. You give it your own version of 1,000 somethings or other, or up to 1,000 somethings or other, and you just say, as it's been doing all along, okay, guess what would come next? If this were in the corpus, what would be the next thing? And then, of course, you can ask it, what's the next thing after that, and so on. So to get it to perform automatic programming, you give it something that looks like a comment that might appear at the beginning of a program. And you put text into that comment that says what you want the program to do. And it says, so to speak, it's impossible, I find, to talk about this stuff, or impossible for me anyway, without lapsing into anthropomorphic language. So I'm just going to do that. So put scare quotes around it, to suit yourself. But anyway, so you give it this comment, and it thinks to itself, so to speak, if this comment were to appear in the code base, what would come after it? Well, of course, the code that implements the comment is what would come after it. And remarkably, that actually works. Okay. Now, GPT-3 isn't writing code, but GPT-3, it turns out, will give you appropriate responses to a wide variety of questions. And you can give it anything, and it will come up with what it thinks is a reasonable continuation of whatever you said. And that's very often extremely interesting. I'll give you an example in a little bit. Well, actually, here's one here. So this is GPT-3. So suppose you type into GPT-3, who discovered America, ? It thinks, well, actually, take a minute to think what you imagine it might say, keeping in mind that from its point of view, it's not doing question answering or any other sort of human task. It's just saying, if this showed up in the corpus, what would come next? Okay, so form your own idea of what it might say. And here's what it did say when I asked it. So there's no single answer to this question. There's no agreed upon meaning for America, blah, 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 blah. The details don't matter. But two things are interesting. One is this is pretty apt. It's a pretty reasonable, maybe even a sophisticated answer to this question. And it's worth reflecting on the fact that no human being crafted this answer. So nobody had to say, what would be a good answer to the question, who discovered America? Other than such things may appear here and there in the corpus. It has the ability to scavenge and synthesize that kind of stuff to come up with this. So pretty remarkable. We'll say more about this in a bit. Okay, but we're here to talk about the implications of this technology for personal assistance. And as Ted mentioned, I mean by that, assistance for people who need them because they have cognitive limitations. So does this technology offer anything in that space? And to discuss that concretely, I want to consider a real life use case. So I have a friend who's a brain injury survivor. And remarkably, she figured out that anybody, nothing to do with having a disability, anybody with the funds can employ a remote human assistant. Okay, this is a service. There are many of them, actually. Her particular assistant happened to be in India. And one of the things that's, and she's in DC, one of the things that's interesting about that is that she's interacting with this human assistant through a very narrow and you might think manageable channel, telephone and email. And interacting only over that channel, this human was able to be very useful. And I'll talk about one aspect of that in a second, but I'll observe along the way, she stopped doing this after a couple of years. And of course, I was interested in why she stopped. And what she said is very relevant to this conversation. She said, even though it was clear to both of us that this personal assistant was my paid employee, I still became uncomfortable asking them to do the kinds of things that I needed them to do. I was uncomfortable having that relationship with another human being. If you gave me an artificial assistant that could do that, I'd be on it like a shot. Okay, so an interesting thing to reflect on. Well, could we have an artificial assistant that could do what this human being did? Again, there are lots of things that a face-to-face human assistant might do that we don't have to talk about because that wasn't a possibility for this actual human assistant. So we might say, well, yeah, we ought to be able to put something on the end of a wire that would do the kind of thing that this person did. Well, let's look at just one small snapshot of that. So one of the tasks that she asked her assistant to help with was keeping track of gifts. So my friend is a very social and very generous person. She gives lots of gifts to lots of people on lots of occasions. And after her accident, she found she couldn't keep track of what she had given to whom, which is very embarrassing. So, gee, Ted, have another coffee maker just like the one I gave you on your last birthday. So to avoid that, she asked her assistant to keep track of gifts. So the assistant couldn't know when she gave gifts, so she would tell him, okay, I'm proposing to give Ted a coffee maker for his birthday. The assistant created a spreadsheet with the information about what she'd given to whom. And so he could check that and say, you need to pick something else because you gave Ted a coffee maker on last birthday. I'll just note that there's a term for what the personal assistant did, term of art, which is interactive task learning. You can look it up. And there are people, John Laird of Michigan is one of the leaders in that subject. And what interactive task learning is working out how to do something based on some kind of verbal description, or ideally emphasis on interactive, by engaging in some sort of conversation about it. And I'll just note that as of a couple of years ago, I had an opportunity to talk with John as part of a workshop about what was happening in this space. And John said, well, our community is making some headway on this, but we really can't do anything outside constrained artificial environments such as gameplay. And he said, this use case that we're talking about here was way out of reach for them. That was a couple of years ago. I'll just note that community at the time, at least, was dominated by what's often called good old-fashioned AI. And, they were making some progress, but not a lot. So the question arises, okay, does this different kind of AI offer anything there? So, could Codex actually perform this task? Okay, so a little bit about working with Codex. So I've already told you part of this. So all you ever do with Codex is you give it this thing that's called either a condition or a prompt, and it's gonna tell you what it thinks comes after that. So as I already said, what you often want to do is to format what you're asking it to continue as if it were a comment in some language, which incidentally cues it to what language you're interested in. Well, there'd be other ways you could do that. But let's say you just have a comment that's formatted as an HTML comment, and you might put in, before that, the first few lines of a typical web page, and then you say, okay, what would come after this? And what it's going to fill in is the HTML and necessary JavaScript for the page that does whatever it is that you said in the comment. And I've already made this point, but it's worth making again. Codex hasn't memorized the code. What it's doing is synthesizing code that, according to the regularities it has detected in the code base, code that obeys whatever those regularities are that it's identified. Okay, so if what you want is something really simple, you'll find that you can put a request for what you want into the comment, and it'll actually give it to you. And when I was first working on this use case several months ago, I was new to Codex and naive, and that's what I was doing. And what happened was it did a pretty good job, but unfortunately the code it produced didn't actually work. It came kind of close, but it didn't actually work. So that was progress, but obviously not where anybody would really need to be. So to get further, if you have more complex things that you want to have, you need to work with a sequence of these requests or prompts. So there's an interesting sort of relay or bucket brigade process that you engage in. So you start with some initial requests, and you want to keep that pretty simple. If you ask for too much, Codex won't be able to get all of it, and so you're not going to be happy with what it gives you. So you ask for something simple, and if need be, you may have to iterate a little bit there. So if you're not happy with what you get, maybe to simplify your request a little bit, or maybe just ask again because it's stochastic. So it may happen that the same request might sometimes give you what you want and other times not. Anyway, so you fool around a little bit until you get code that you're happy with for the initial request. Well, once you have that, your subsequent request, your next request, is a kind of a composite. So you give it back your initial request, followed by the code it gave you for that, and then you give an augmented request. And when it continues that, if you're lucky, you'll get code that fully implements the augmented request. And you can carry on like that. So each time you're giving it a previous request and what it gave you for that, plus a more ambitious request. And you might wonder, what's the point of giving it back what it already gave you? Well, it's important to realize it doesn't have any memory for any of this. So the only way it gets access to the code it generated before is if you give it to it. But it turns out it is able to process stuff that you give it back in the conditioner. So that actually works pretty well. As you can see, this is kind of tedious. In real life, if one wanted to do this, you'd probably want to have some tooling. And I have no doubt at all that there are people at Microsoft and other places who are developing exactly such tooling. But anyway, we're talking here about bare metal Codex, so you can work with it this way. So what happens when we do this? Okay, so I started with a very modest request: create a web page with the title gift list, show a list of names, Fred and Ethel, and then I want something that starts with a doc type. And it won't surprise you, I think, that it can do that in one go. It gives you that code. So I then give this request and the code it gave me for that, which I was happy with, and a more ambitious request. And in a total of 5 prompts, I ended up with the prompt that you see there: create a web page with the title gift list, add a text box called blah, blah. I can't read all of this on my screen, unfortunately. But anyway, write a script so that when I type a name and gift in the box and click add them to the list, but don't show the list. Add a query button when I type a name in the name box and click query, show the gifts I've given that person. So I'll just note here that, am I completely agnostic or ignorant of the world of web pages? No, I know that there are a thing called text boxes and there are buttons and that sort of thing. But you'll also see that I don't need to know anything about how you would create a button or how you would link a button to code or code to a text box or any of that stuff. Okay, so it takes that last request together with the code from the previous request and the previous request, and it generates something that gives you this. Okay, so that's the web page. So you see it has an add button and a query button. I didn't notice when I was doing this, but there are no labels on the text boxes. So when I was last sort of going over this material, I realized that. So this gives you a further look at what this interaction process is like. So having noticed that, I gave it back the request you just saw, together with the code that I didn't show you, but that produced that web page. And then I gave it this augmented request with the text in red added, show the names of the text boxes. And when I did that, then I get the web page that you see here, which is just like the one before, only it has the names on it. Okay. So again, note, I didn't have to know anything about how you would put names on text boxes. Okay. It just It just does that. Okay, well, you might or might not be impressed by this, but as a feat of automatic programming, but as something useful, it's a complete non-starter because it just keeps track of this information, in the browser. There's no persistence involved. And so, of course, I wondered, well, what's involved in getting it to do something with persistence? So there'd be a variety of ways that one might do that. Well, of course, you might wonder if it's possible at all. And so the reason I'm telling you about this is, yes, it is possible. So here's how I approached it. So I thought, well, maybe I'd like this thing to work with a Google Sheet because I knew there was an API for Google Sheets. And so I thought, okay, if I can get Codex to generate code for the Google Sheet, then I might be in business. So the approach I took maybe needs a little bit of explanation. I thought to myself, if ultimately the idea is that somebody who doesn't know anything about programming could do this, we don't want to have the process require knowing any of that. But somebody who does know about programming could provide some resources that somebody who doesn't know about programming could use along with Codex to kind of get this done. So I thought, okay, it would be fair if somebody who knew about Google Sheets provided some example code. They wouldn't know anything about what you were going to do with it, but it would just be examples that would convey or illustrate or exemplify for Codex how the Google Sheets API works. So I thought, okay, it'd be legitimate. You could imagine a tool that would just have that stuff in it and add it to prompts, or maybe there'd be some little dialogue with the user to determine whether the stuff was even pertinent. But if it were, this stuff would just be stuck in there invisibly to the user as a kind of a header, you could think of it. So I thought, okay, that's legit. It's not assuming that the end user knows anything about that stuff. So let's see how that works. Okay, so as it says here, I wrote some generic code for sort of examples of writing and reading to the Google Sheets, and then I followed that with a sequence of prompts, ending with the one that's shown there, and the result was this web page. And actually, I hadn't thought to ask for the names on the text boxes. Of course, this doesn't look any different, but what's different is the code that's generated actually uses the Google Sheets API to store and retrieve data from the spreadsheet. Okay, so a few things about this. So first of all, if we look back at the request here, create a web page, blah, blah, add a text box. When I type a name in the box, add it to the list with the gift in the gift box, add a query button. Nowhere in here did I say I wanted an add button, but the code actually has an add button. So that's one of the features of working with this tool. It's always fleshing out, you could say, what you've asked for explicitly with stuff that in its experience, again, speaking anthropomorphically, is highly correlated with that. So you could say that it's enacting the fact that in the corpus, when people do stuff like this, they always have add buttons. So I get one, even though I didn't think to ask for it, okay? Then something that's a little more subtle here has to do with the read and write aspect. So I mentioned that I started out the thing with a couple of code snippets, one of which did writing and one of which did reading. But in the early going, in the early prompts, I only asked for write operations. So I asked it first to sort of store the names away, and only later did I ask about retrieving them. And in the course of doing that, I didn't even notice it. But because I had only asked it for write operations, the code that it had given me, and hence I was giving back to it, had only write operations in it. Any code involving read operations had vanished from the sequence, so it wasn't in there. And yet, later on, when I added a request to read, not only did I get read operations, I got the appropriate read operations for the Google Sheets API. So as it says here, that tells us two things. So first of all, and I should have known this or thought it was likely at least, there's enough use of the Google Sheets API in the corpus that it can cope with that. But that's not enough. It had to figure out from the fact that I was writing using the Google Sheets API, that when it came time to read, I needed to read that way. Okay, so if a person did this kind of thing, we'd say they had a pretty good understanding of what was going on. Okay, so to me, this is remarkable about the character of this tool. Okay, so one disclaimer, nothing to do with Codex, everything to do with me or maybe me and the Google Sheets API. I couldn't actually deploy this or any of the other examples that I tried using the Google Sheets API. I got mysterious error message and all that. So what's the significance of that? It means that we can't be sure that the code that was generated here would actually work because I wasn't able to deploy it. I can just tell you it looked right to me. But I'll assert that whether it's right or not really doesn't have anything to do with what Codex is doing, which is our subject here. But more substantively, if we were to think of moving this towards real life, replacing that human assistant, there's still some gaps. So yes, the human assistant needed to create a program. Actually, probably the human assistant didn't create a program to do this. They probably just used the spreadsheet to do it. But at any rate, notice that Codex can't use the spreadsheet. It can create the program for using it, but it can't actually do it, nor in its present form. This is something I think that could be explored further, though I haven't done so. There'd be a question, could we move towards having a conversational interface to the whole thing, which is what the human assistant provided. So the human assistant not only did whatever they did sort of in the back room, but they allowed my friend to interact with whatever they created through them as the medium. So they could say, I'm proposing to give Ted a coffee maker, and the agent carried it, took it from there. And of course, what I'm showing here doesn't do that, that part of it. So another observation is that what I had to do to create the program, I don't think I've lied to you in asserting that it didn't require knowledge of programming in the usual kind of sense, but you can still recognize it's quite far from a natural kind of conversational interaction of a sort that a human assistant might offer. So that's significant as well, and I'll say more about it in a minute. So the interaction that's required has a particular kind of structure to it, which you have to learn, and it's not very natural. And I think it's fair to say that many putative clients for something like this probably would have difficulty carrying out that stereotyped process. I'll also observe that it's conceivable that you could have tooling that would deal with maybe even all of the things that we're talking about here, but I think it would be ambitious to do that. But it may happen. And as you probably know better than I, there are legions of capable people working on all of this stuff, which is something I'll come back to later with respect to other issues. Okay, so stepping back from that little example, what's the general character of these language model-based systems? So I'm going to make a claim, maybe contentious, that this technology has much greater potential for matching human conversational behavior than any previous technology. And further, why are we talking about that? I think we can agree that supporting natural human-like conversation is probably important for many personal assistance use cases, where the natural way for someone to interact with an assistant would be through a conversation. So what about that? So my colleague Jim Martin, a few years ago, when I was kind of asking him, so Jim, what's the state of the art in natural language processing? He said, well, we can do all kinds of things with languages, as long as you don't ask us to say what it means. So I wondered, of course, well, what's the problem? So, I should also say corollary. It's amazing what you can do with language without understanding what it means. And, we probably don't pay attention to how often that's enacted, right? So, in my lifetime, language translation has gone from literally a joke to being a workaday, very practical kind of thing. And, we all know that happens utterly without the system understanding anything about what you're saying. It doesn't have to understand what you're saying in order to do the translation. So that's an example of what Jim is pointing to. But suppose you did have to understand what's going on. Jim was saying, that's an issue. He said, well, these recent developments make it less of an issue, but nevertheless, I was interested. So what's the problem? What's the barrier? So I have two other colleagues who are linguists who specialize in human conversation, Barbara Fox and Chase Raymond. When I asked them about this, they said, well, not only are these systems not able to have real conversations, but having real conversation with artificial agents is in principle impossible. So of course I asked them, well, why would you say that? And the answer was, read Harold Garfinkel, and consequentially Chase added, and read John Heritage. So this is advice to any of you who might be new to Garfinkel or maybe even who are familiar with them. I had engaged with Garfinkel's writings before, but I'll tell you that Heritage clarified an enormous amount, some of which will come into my brief discussion of Garfinkel here. Okay, so Garfinkel was a student of Talcott Parsons at Harvard, and Talcott Parsons was probably the most influential sociologist of the 20th century, certainly American sociologist. And as happens not infrequently, Garfinkel rebelled against Parsons, but Garfinkel never makes that very clear. Heritage is where that's explained, and that's one reason why Heritage was so helpful to me, and I think would be to you, again, if you're seeking to understand Garfinkel. So what was going on there? Well, another little note that may be of interest to those of you that have cognitive science interests, Heritage gives some quotations from Parsons, and I'm reading one of them, and I'm saying, boy, this is really familiar. What he's describing here is the way the pioneering AI program, the general problem solver, works. Means ends problem solving. So I think to myself, gee, that's interesting. I wouldn't have expected that sociologist Talcott Parsons would have been reading the early AI literature. Well, come to learn, I had that completely backwards. What was happening was that the early AI researchers were reading Talcott Parsons. So means ends problem solving actually originated, the idea of it originated in the work of Talcott Parsons. Okay, and then that led to the whole tradition of symbolic AI and scripts and frames and all that sort of stuff, which became mainstream cognitive science. Garfinkel said that all can't be right. All this abstract machinery, it has no hope of accounting for the observed complexity of human conversation. And he calls attention to what he calls the conversational fringe. So you think you can make something out of what's said in a conversation, but what's said in a conversation is often the least part of what's actually going on. What actually is happening in the conversation involves the delicate interplay between what's said and what's already known and what's known to be known by the participants and all that stuff around the edges. And Garfinkel is saying, you just can't account for all that stuff using these scripts and frames and all that stuff. They can never be sufficiently flexible to account for that. So, as many of you will know, maybe all of you, Garfinkel has his descendants. Garfinkel's no longer with us, so his descendants are the ethnomethodologists. And this is, of course, my personal take, but my take is this literature ends up being strange and poignant, because what they've inherited from Garfinkel is the belief that abstract statements about human behavior can't possibly be right. And so they're trying to get you interested in what they have to say about human behavior, but they're committed to the notion that no general statement about human behavior is possible. So for many people, that means it's hard to get too interested in what you're reading. But at any rate, my argument is that they were cast in this kind of negative stance because they didn't see these systems that we now have that can serve as models of how it is that cognition or something like it can happen without rules, scripts, concepts, and other such machinery. The argument is that we learn from this that perhaps the way our cognition is organized is that we, like these systems, are simply noticing and enacting regularities in the environment. So instead of having structures in the head, we're just enacting, observing, or recording and enacting regularities. So a little more about what this might mean. So here's an example actually from GPT-3. You can find this in one of the early kind of reports of the system. So in this case, you're going to type into GPT-3 1 Batman, 2 Superman, 3 Cyborg, and then you're going to say, what comes next? And GPT-3 continues, 4 Flash, 5 Martian Manhunter, 6 Green Arrow. So what's going on there? Well, maybe we can all tell what's happening here is that it's being given a bunch of superheroes, and it continues with other superheroes, but there's actually more that can be said here, not by me, because I don't know enough about this stuff, but those who do point out, oh my gosh, all 6 of these superheroes are DC Comics superheroes. So if a person did this, I don't think we'd have any hesitation in saying, well, of course, this system has the concept of superhero. Not only that, it has the concept of DC Comic superhero, and maybe we'd say it must follow from that it has the concept of DC Comics. Observe also, it evidently has the concept of numbered list. Well, I'll assert to you, it has none of these concepts. What do I mean by that? You could paw through the billions weights in this system, and there's not going to be any data structure that represents the concept of superhero, let alone DC Comics superhero, nor is there going to be any organized body of information that represents the concept of numbered list. Rather, the list we see here results from the enactment of a whole bunch of regularities which together generate this particular behavior, but none of them could be isolated as representing a concept like numbered list. Here's another example from what Codex had to do along the way in the interaction that I just kind of outlined for you. So I mentioned I gave it sort of an example program to sort of give it an idea of how the Sheets API works. So the example was create a web page with the title price list, add the item eggplant and price $1 to a list, then display the price for eggplant. Okay. So then it gives me code for that. And then I give it back and I say, okay, now against that background, create a web page with the title gift list, add the name Fred and gift necktie to a list, then display the gift for Fred. So it produces code for that. Again, if a person did this, we would say, well, they've struck an analogy. Okay, there's an analogy between the code that deals with price list and the code that deals with gift list. Okay, and indeed, I'd say that's a perfectly reasonable account of what's going on. Many of you will know that the mainstream account in cognitive science of analogy is what's called structure mapping, which means you have 2 conceptual structures and you're forming relationships between the 2. Again, I'll assert to you that Codex lacks any cognitive structures. It has stuff and it's able to trace relationships between bodies of stuff, but it has no structures that are being mapped. Parenthesis, some of you may be thinking about this. Well, come on, Clayton. What do you mean it doesn't have structures? If it acts like it has structures, doesn't that mean there's a sense in which it actually has them? Well, I think this is a really good argument. I'll suggest that there's a parallel, which maybe is informative. If we were to be talking about virtual memory, well, yeah, there's a sense in which a machine with virtual memory, you might as well say it has a large memory. For many purposes, that's a perfectly adequate description. But equally, we all know that there's a sense in which it doesn't doesn't have a large memory. And I would say in this case that if we just say, well, these things act like they have concepts, so let's just pretend that they do, to me, that loses the opportunity that these systems offer to think differently about what's happening in cognition. That we get a different idea of what's underneath the hood, and that may be a productive different idea. I believe it's likely to be productive. You might, or anyone might have a different idea about that. But anyway, I just want to note this virtuality point because I think it's a serious one. Okay, so continuing with Garfinkel's structure aversion, let's move to this conversational fringe idea. Well, we've already seen a couple of illustrations of that in this programming example. So I never talked about an add button, but just as a person might do that, Codex filled it in. Yeah, you didn't ask for it, but this is kind of in the air. This is what you should have, that's what we're actually talking about, even though you didn't mention it. Another example we also mentioned was, I never said what API it should use, but lo and behold, it ends up using the right one. Okay, so it's appropriately sensitive to the nuances of what's going on. And, again, reflect on how different this is from the behavior of normal programming tools, where if you don't say something explicitly, it ain't happening. Okay, something I haven't told you about, but from another project, and this really took me aback. I won't take you through all the details, but I had gotten it to create a web page that I thought was kind of cool, and I wanted to publish the web page, but I realized if I just put the naked page up there, nobody would know what to do when they got to it. So I wanted to add some descriptive text. How hard could that be? Well, it turned out unexpectedly it was quite hard. I kept giving it, here's what I asked you to do. Here was the code you gave me for that. Now give me that page with this text on it. Seemed perfectly straightforward, but persistently, I just got the same page back again without the text added to it. Until, and I don't even remember why it occurred to me to do this, I had said, give me a web page called blah. And when I changed that request to give me a web page called blah with legend, it added the text. Okay. So to me, that's the note of humanness that we're used to not having in our computational tools. Okay, so I've taught intro, probably many of you have too. And so you'll know that, there are two linked issues that are a little bit tricky for students, and you have to get them across. So one is, you might think that it doesn't matter what names you give your variables, because a lot of students start out thinking of variables like in math. So I'm going to call them X and Y and J and stuff. And so you have to say, no, this is a real resource for you. Be careful what give thought to what you want to name your variables, because that'll really help you understand. So that's one point you have to get across. But the companion point is, but don't make the mistake of thinking that the variables you choose have any impact on what the program is going to do, because it won't. Okay, and that means that just because you read the line of code and it's clear to you what it's going to do, that doesn't mean that anything about what's going to happen when that code is compiled. Well, against this background, this is just shocking. Okay, because what could be less relevant to anything than the title that you ask for on a web page? And yet, as Codex views things, it's highly relevant. So like people, Codex is free to and does respond to any particle of predictive substance that it discerns, whatever its formal role might seem to be. And again, I'd say that's a marker of how this is moving into Garfinkel land. Okay, just as people refuse to be constrained by boundaries associated with scripts and frames and stuff like that, you just can't capture what they're doing that way. Same is true of this system. Okay. Less good news. So a huge limitation in these systems as they exist right now, and of course it's a moving target, is, and we've alluded to a little bit of this. So what counts as its memory is very weird with respect to any kind of person. And here the scare quotes are really needed. Okay, so you train GPT-3 up on this vast corpus, which includes stuff, as you saw, like stuff about Columbus or whatever. So that's all there. But whatever it knows was utterly frozen at the time that it was trained, which is a few years ago now. So anything that's happened since then has no chance to be represented in the corpus. Okay, furthermore, not only was it whatever it knows frozen at some date in the past, but the content, you can tell how vast the corpus was, it doesn't include almost all the personal information that people have and manage every day in the world, because that just doesn't find its way into these public corpora. Okay, but so in addition to whatever it, quote, knows, unquote, from the corpus, it also knows, unquote, what you, quote, unquote, what you give it in its prompt. But two things about that. First of all, the prompt is very limited, roughly 1,000 words, something like that. And actually, the OpenAI people have done some amazing stuff, like compress all of the documentation for the Word macro API down to fit in there, and then they showed that it could generate code against that. But anyway, it's very limited. But beyond that, it's totally transient. So it's not the case in the interactions I was describing to you that I ask it for something and it remembers that. It only remembers it if I give it back to it. Okay, so huge limitation. Well, we can tell that for a credible personal assistant, this just isn't going to fly, because one of the major things a personal assistant needs to do is to manage that sort of autobiographical information. So a very real example would be, when's my doctor's appointment? Okay, so that's, doctor's appointments come and go, and the system has to be able to accept information about doctor's appointments. Just one of gajillions of examples, and many of you know, this kind of knowledge is called by the psychologists episodic memory, and these systems don't have it. But there's recent work, which I think is quite promising, in suggesting how that limitation might be relaxed. So this is a system from DeepMind called Retro. And Retro is trained in a different way. So these other systems are trained to kind of make these predictions any way it can. Retro is trained to make them in a particular way, to use pieces of documents. So being sensitive to the structure of the corpus of documents, use pieces of documents to make its predictions. And the force of that is that it learns how to do that. So how to use a piece of a document to make a prediction. And that means that you can add new documents to the corpus without having to retrain the thing. You just stick them in to the corpus, and it has the ability actually to make use of them. So this is potentially a huge breakthrough. I mean, there's still a long way to go between that and anything as flexible as human episodic memory, but at least it's a start. It's saying, so you can imagine that, you stick a page into the knowledge base that has information about yesterday's or next week's doctor's appointment, and there's some hope that it could find and use that that information. But I alluded to this before, and again, you probably all know more about this than I do. There are just legions of really capable people whose efforts have been sucked into the enterprise of developing the technology we're talking about here. So it seems that every week there's a major breakthrough in this space. I see no reason to think that progress is going to slow down. So I think there are very real prospects that this technology may evolve from where it is now. I've tried to give you an idea of what I think the basis for thinking it's promising is. But anyway, wherever it is now, I think we can be confident that it's going to move very quickly in the directions it will have to move to be useful in this way. I'll add the comment, and maybe some of you are in a position to do something about this. I haven't done a systematic look at this, but I've done a little bit of looking to see, is anybody who's doing this work thinking about the implications of it for people with disabilities? And as far as I can tell, the answer is no. So interestingly, almost every paper on this material now has a broader impact section in which social impact is discussed, but the impacts are, I would say, 99% negative. So the AI community has been scared, probably correctly, by public criticism and reaction to potential abuses of the technology being developed. they're very aware of that and very concerned about it and discuss it in virtually every paper now. It's quite interesting. But the other side of it, gosh, what good could these technologies do for us? People don't seem to be thinking about that. And I think it would be great if they did, for probably reasons that are obvious. Okay, so while I'm arguing that what these people are doing, following their own noses, is potentially quite useful, it's not hard to see that it might be even more useful if at least some share of the attention went into thinking about how it might be deployed in settings such as the ones we've been talking about here. So, summary, I think there's exciting stuff practically, but also maybe even more theoretically, that is, I think, what this suggests about how cognition is organized. Maybe the long run is going to be more important than the other stuff. And then, of course, I need to thank a lot of people, my colleague Anthony Basman, Barbara Fox, whom I mentioned, Pam Gregory, Catherine Hermano and Louis Chase Raymond, and Jason White of ETS for very useful discussions of all of this. And so I want to know what you all think about all this. And so I will thank you all for your attention and look forward to questions, comments, and complaints.
Wow, Clayton. I've been involved with AI and human-computer interaction all my life, and I have to say that you brought up several points that I've never heard brought up before, and I put them in the comment section a little bit. Really kind of feels like a singularity around supporting people in their desire to do things that they don't have time or the abilities to master on their own. So very exciting to me. William Feth, you have been commenting so much during this talk. Is there anything that I can interest you in just saying very briefly or asking? That would be kind of
it was just a really stimulating talk. And I was thinking as I was typing, like, I need to stop, I need to pay attention. It was fascinating what you were saying about how the code comments would drive what code comes after them.
Yeah.
That got me thinking about my code commenting style. It's usually very terse and has nothing to do with what the code actually does.
Yeah.
It's more like my future plans, like what this should do because I didn't have time to make it do that.
Yeah.
Or, note to the next person, usually my future self. This bug exists, beware of not taking this too seriously, that kind of thing. So I wonder about the corpus. And then it occurred to me that maybe they were farming the Git commits. That's like the human to human chatter about a particular block of code. When you make the change, you can sort of comment about what it does. And that never appears in the comments above the code itself. It's in an auxiliary part of the database.
Yeah, it's an excellent question. So first of all, I mean, if somebody had said, we're thinking of doing the following, what do you think? I would have said, no chance. It's not gonna do anything interesting. And I mean, and I no doubt you're right that it can't do much with your code, but apparently the remarkable fact is that in the aggregate, everybody's code does pretty well. I'm going to guess, I don't know this, maybe somebody on the call does know. I haven't looked in detail at even whatever might have been disclosed about the details of Codex's corpus, and there may well be good information about it. My guess is it doesn't have that auxiliary stuff in it, in part because if you think about it, that's not really in the spirit of this just what comes next kind of stuff, right? So somebody would have had to say, well, these comments go with this body of code, and maybe they did that, but I doubt it. I mean, but I wouldn't bet very much money on that. Yeah. But anyway, I share your
thinking.
Your
question.
Yeah,
so
more questions.
Another interesting thing you brought up I liked was this thing of adding this word legend.
Yeah,
really gave it a clue, and it reminds me of the idea when an idea is missing, it's hard to know how to look for it, but when it's there, you have something to grab onto. I don't know if you want to say anything more about that that point.
Well, I mean, I guess I assimilate it, and I may be starstruck here, or whatever, the system struck or whatever, but that really did hit me between the eyes. Okay, because it just seems so starkly at odds with what we've come to expect from our technology, right? So we expect our technology to stay within its lane, okay? And it's just obvious that its lane and our lane are virtually disjoint, okay? There's all the interpretation and purpose and all that kind of stuff that we take it to be our province. And that's not the compiler's business, okay? And so the compiler is supposed to syntactically partition what we say into the stuff that it's entitled to interpret and the stuff that it's not, okay? And of course, it does stay within its lane. But this system doesn't have lanes, okay? So there's no difference from its point of view. Well, obviously, its whole thing substantially is reading the comments, right? I mean, in some sense of that. So right off the bat, it's doing things that no compiler ever does. Somebody could point to some exceptions here and there where with special markup, you sort of signal that some tool will read something that's otherwise in the body of the comment. But to me, that's, again, it's sort of signaling a paradigm shift of the sort that was at stake, as I tried to argue, between Parsons and Garfinkel. Parsons saying, well, we can see all these rules that govern our behavior, and Garfinkel saying, no, it only looks like those things are governing our behavior. And as soon as you push on them anywhere, you find out they all have violations. There's never a rule that. Actually, I'm reminded of a parallel some people might have seen. So the philosopher Robert Brandom writes about the role of logical implication in the world. And people often think that you can describe facts in the world using implications. And Brandom basically says, no, you can't do that. That's not what implication does. The example he gives is somebody might say, if you strike the match, it will light. And Brandom says, well, what if the match is damp? Okay, if you strike the match and it's dry, then it will light. Well, what if it's in an oxygen-free atmosphere? If you strike a match and it's dry and it's in an atmosphere with oxygen, then it will light. Well, what if there's a very strong magnetic field? Well, it turns out if there's a very strong magnetic field, matches won't light. And so at that point, you sort of stop, you say, look, I mean, it's hopeless. There is no logical implication that can possibly characterize when matches will light. Okay, it's not that kind of thing. And I think that's essentially Garfinkel's point. There is no set of rules and structures and so on that governs what we do. It's totally adventitious, and that's what these systems are like. They're regularity avores as we are. They don't care what the regularity is. If it's a regularity, they're on it.
Right. So I've just looked at the closed captioning, finding the word evidentiary that you said perfectly. I think Nancy's with me. That was completely shocking. And it's an example of it really reaching out to gigantic corpus. I guess what I was just thinking about as you were talking about the match is I was thinking about Minsky. And now Minsky was always talking about, accumulating from baby and getting smarter and smarter. And he had these, rules and stuff and just a messy glom of things. And I just wonder if, I know, and I asked him, hey, why aren't we learning from the web? He says, oh, we can't learn anything from the web, but of course he was wrong. I kind of pushed him on that many times. He's now gone. But just you're reaching back to some fascinating historical figures, who I haven't studied. And Simon and Minsky and Selfridge, all these people had comments on this topic. Is there any of those people that you want to just bring up for a moment so people that aren't aware of or their positions might see how this stuff is?
Well, beyond referring to just very sketchily to the means ends problem solving, the whole symbolic AI tradition is basically in that. And actually, in this workshop that I mentioned that I'm attending, there was discussion on this point today, and actually I want to credit was bringing. don't know if people know Nick Giudice of the University of Maine, who's one of the participants of the workshop. And Nick was observing, he's a blind guy, and he makes a lot of use of Alexa. And he was saying, my Alexa's getting worse. It's not getting better. It's getting worse. Why is that? Well, Jonathan Gruden, I'm sure others, have commented on that phenomenon. And what it reflects is that Alexa is actually very old technology. And so far, any day, I imagine this will change. But so far as I know, Alexa is still this old technology, and it's not the kind of thing that we're talking about here. Why is that? And what's the difference there? Alexa is a bunch of rules. And the nature of trying to cover things that way is that, and Gruden has commented on this, there's pilot project after pilot project of that class of system that gets really great results because they only ask the thing to discriminate 3 kinds of things that you're interested in, okay, which they take as proof of concept. Well, the problem is techniques that work when you have to discriminate 3 things don't work as well when you have to discriminate 10. And maybe they start not working at all when you have to discriminate 100 or 1,000, which is what happens as the systems become more and more ambitious. So this rule kind of stuff, it's like random and the matches, okay? You keep piling on more and more considerations, and it's just not going to work. I mean, you can never add enough conditions to sort of capture everything. You just get a huge, sort of complicated mess. So I could characterize this as discrimination-based technology. It's trying to differentiate situations. That's sort of how code of the usual type works. These systems, you could say, are integrative systems. They're not trying to differentiate stuff. They're trying to integrate stuff. So the more, if you're integrating, the more stuff you pile in, the better, okay? Because you're not trying to keep it straight. You're just trying to extract regularities from it. And the more stuff there is, the more regularities you can find. And then you could say further that one way to think of the difference is instead of a bunch of ifs, which is, as we know, this is just going to be brittle, right? So the if has got to do one of 2 things. And, if it's wrong, you're hosed. These things work by weighted sums, okay? So it's not, is it A or is it B or is it C? It's, well, this might be a little bit of A and maybe some more B and maybe some C and maybe some D and maybe some E and maybe some F. And then it sort of weights all of that stuff and something emerges that actually is a pretty sensible thing to do in the circumstance. But the character is so different from the sort of decisions baked into code, which Alexa represents.
That's really interesting because it really, it focuses on this issue of how do we get a representation. And we used to talk about associative memory as this dream that we would get to that would, support AI question answering. Selfridge already talks about that.
Yeah.
Any thoughts about how this relates to associative memory?
Well, yes, and actually, unfortunately, I'm now of an age where retrieving proper names is extremely dicey, but people probably recognize there's actually something called memory-based problem solving that was later than Selfridge, but more recent. On a good day, I can come up with a name, but if you Google it, you can find that. And that anticipated some of this, but it didn't anticipate the integrative character. So the notion was you'd store very many patterns, and then you'd match the patterns and you would do what the patterns said, but it didn't have the integrative kind of character to it. But it was kind of in the right track of saying, we want to have systems that work by accumulating large amounts of knowledge and somehow trying to act on that rather than having a bunch of rules as such. So, it's a step in the right direction. That's one thing that comes to mind. And I guess maybe there are, again, I've never really made a study of associative memory. Was associative memory designed to work in a sort of an approximate sense? That is, if you had something that was something like something that you had stored, did you have a hope of retrieving something, or did it have to actually match?
Well, I think it was a conceptual direction as much as it was any implementation.
Okay.
Right? So it was really a cognitive model. Nancy has a big history in this interpreting language stuff. Nancy, do you have any questions or comments you want to add?
No, I'm fascinated by, I haven't heard about Codex. I haven't been working in this part of the world for a long time. So I'm fascinated by what it can do. And I was also fascinated by William's comments earlier. William, do you want to say anything about your dementia comment? Which seems to relate here.
It was that it seemed like GPT-3 and Codex sort of stringing one thing after another. It felt a little like some of when I've been with a relative who has dementia, they'll say something that's, a 3 or 4 word answer that totally makes sense. But then as they continue, it sort of extrapolates into this nonsensical, like, the corporate, the total of what they said doesn't make sense, but the short answer does.
Yeah,
that's
that's
what's missing from their cognition, and therefore maybe what's missing from our AI.
Yeah, well, that's a shrewd comment. But actually, something I wanted to mention in case some of you are interested in digging into this stuff. OpenAI has made it very easy to do that. I mean, I'll put a hedge around that. But actually, I don't know what the state of play right now is. But at one point, I was able to get into some free trial or onto a waiting list for a free trial or something like that. Anyway, it matured. And then at some point it transitions to a paid subscription, which I've now had for some time. And I wanted to pass something on about that, because you might worry, as I did, well, what am I getting in for? Okay. But in the sign-up process, they explained that they had sort of guardrail things that, if your account ever reached so-and-so, they'd warn you. So I thought, okay, I'll take a chance. Well, I'll tell you, I've been using it moderately for some time now, and my monthly invoices are like 81 cents. Okay. So if you're curious about this, I encourage you to dive in. The only hedge is, I don't know how quickly, it's possible you can sign right up, or it's possible that you have to be on a waiting list. But I've found it really interesting. Actually, maybe I'll add something else that didn't really come up here, but it's taking a lot of my time. It turns out that GPT-3, actually, I can show you this. Let me share my screen again here. Oh, I'm already sharing my screen. Okay, so I just have to get out of my presentation and see if I can find my browser.
So this GPT-3 acting the way that William described is we've all seen that. What I guess was new to me tonight, that if anybody, I saw many people came in halfway through, that Clayton talked about that I really found amazing, was him describing a web page that had a table on it, introducing a person's gift list and who they'd given it to, and it creating it from just them asking for that with a couple of sentences, making the web page, making the slots, putting up a graphical interface for it. So that's kind of what all of this chatter is about, if you came in a little late.
So I wanted to indulge myself here by,
Please.
okay, so where are we here? Okay, I don't want that.
You may want to move your page up a little bit so that we get.
Yeah, hang on. Well, I've got to get, here we go, the playground.
Okay.
Okay, all right. So let's see what engine we're using. Whoops, that's not what I want. That filter. Well, okay.
No, do it. We're interested.
Hang on. No,
he's trying to find his. He's trying to get the right spot.
There's a particular setting, but I don't think it's going to matter.
Okay.
Okay. So let's first do a very simple example.
Mm-hmm.
Okay. So this is a meaningless sequence of isolated letters.
Sure.
So one of the settings that I didn't mess with is to tell it I don't want all this. So somehow this interface is a little different when I use it. There's a way you can tell it only give me 8 tokens or whatever, but let's just pay attention to this actually that much of it. Okay. So it said, gosh, what follows RxN? Oh, I see, it's JDW. Okay. So why is it doing that? I think we can agree that nothing much like this ever occurs anywhere in the corpus, and yet it does that. Okay, and this one actually, I think you can make some sense that, well, maybe this is the sort of thing it has to do when it's putting pieces of words together. You know, if it sees the first few syllables of a word, it's a reasonable bet that the subsequent syllables that word follows. So you can tell a story about that. But let's raise the ante a little bit here. So let's do this. Let's see. I'm hesitating. There's so many examples I could give, but let's do. Well, here's a fairly simple one. No, that's not good. Okay, let's do this. Q G W A W G Q R C A C R Q P O A. Okay, so to have pity on me as a human being, I'm covertly introducing some mnemonic value for me. So I'm thinking Q is question and A is answer. So if the question is GW, the answer is WG. So I'm asking it to reverse pairs of letters. Okay.
All right.
So here I'm asking it, so reverse PO, and let's see if it'll do it. No, it didn't. Actually, whoops. Let's just try it again. Okay, so this is not working reliably. Sorry about that, demo-itis. I'll just comment that although I'm trying to choose these letters so as to be meaningless, they aren't really. And so one of the things you'll find is that if I were to choose a different assignment of random letters here, it might well work. So something's distracting it here about P and O. Actually, just for the heck of it, let's try something else like FE. Okay, let's see if that'll work. Nope. Okay, so this one's a non-starter. So sorry about that bum example.
But your point is that it figures out questions and answers just by seeing that there's a pattern.
Exactly. And furthermore, the pattern. Okay, so here's a more elaborate one. So, and I won't do the tedium of typing this in for you. I'll just describe it to you. So I'm going to put open square bracket, some 4 letters, close square bracket, open curly bracket, the same 4 letters rotated 1 position to the left. And I'm going to give it a couple of examples like that. And then I'm going to give it 4 letters in square brackets and an open curly bracket. And I'm going to ask it to continue. And it will do that. Now, if a person did it, you'd say, okay, it's figured out that what's in square brackets is sort of an input and what's in curly brackets is sort of an output, and the operation involved is rotating to the left. But it can do that, but it's not doing any of that. It's just picking up the patterns and doing it. So again, my question is, why is it doing that? Okay, so again, it was taught nothing about that. So if it learned to do that, it's because somehow doing that kind of thing is of value in coping with the structure of the corpus of text. And why is that? Okay, does that tell us something about the structure of human language? Does it tell us something about the structure that's baked into the transformer architecture that these people use? I have no clue. But to me, it's a striking fact that it has this behavior sort of embedded in everything else that it's doing.
Wow. For our user interface practitioner community, could we just give an example that might seem like they would imagine using in their filling out of a form kind of thing? So we'd
well, okay. So another thing you'll find on the OpenAI site, actually, we can look at that. Let's go back here to. Okay, fine. Okay, so these are things you can do. Okay, so what does this mean? Let's take summarize for a second grader. How does that work? Well, you give it a prompt that begins with a couple of examples of what you mean. So here's some text, and here's the kind of summary I want. And here's some more text, and this is the kind of summary I want. Then here's some text. You give me what you're going to give me. And what it'll be is something that's like the summaries that you provided before in some way. And they wouldn't have this here if they didn't feel that, you know, this has some approximation to what you might want to have in some case. So I have
examples in each. If you click on that, it would give us an example or two.
Well, let's see. Yeah, okay, so summarize this. And let's see what it does. Okay, so it'd be tedious to check this out, but you can see, I mean, right off the bat, it's a lot shorter than what you gave it. And maybe it turns out that all of these are words that you might think that a second grader has some chance of understanding, although it seems to me gas planet is maybe a little bit dubious. But what they're not showing you here is that if we were to look at the code behind this, whenever it submits this prompt, it's actually submitting that after some other stuff that's put in there that's the sort of motivating examples that it's providing. But anyway, there's a bunch of these things. Actually, where do we go to get?
I think there's a pull down at the top there, summarized for a second grader, and you can see some of the other ones.
Oh yeah, that's good. Thank you, Nancy. So let's see. Well, so this has been interesting. So even though, as far as I know, the thing doesn't really have much in its corpus from other languages, apparently it doesn't have nothing. Oh, okay. Here's a sort of a program area one. These things, I should say, may not all be GPT-3. There's a bunch of models in here, but let's see what that is. Okay, so this is a little bit like what I was describing to you, only this is Python. And, you know, so it generates Python code. And actually, this sort of illustrates some of what I was saying. Notice here, these are Python comment marks. So when you ask what comes after this Python comment, it's going to be Python.
Wow.
If we change this to, you know, Java, you know, something that was marked up like a web page, it would give you, which is what I was doing.
This might force William into making real comments that describe what he was going to do.
Uh-oh.
Indeed.
Yeah.
Put me out of a job too. That'd be great.
Yeah, that would should also be, yeah.
GPT-3 do my code for me.
Yeah, fat chance.
Oh, okay. Here's
So this is your typical thing.
This is a little dubious, it seems to me, but they're saying that the correction of she no went to the market as she didn't go to the market. Well, maybe, I don't know if that's real non-standard English or not, but oh, okay. They're showing you how they're, okay, let's see how much they're actually showing here. Well, no, okay, so no, they are not. I don't think this is the whole prompt that the thing is eventually getting, but maybe it is in this case.
Yeah.
I'd be surprised if that was
Me too.
But anyhow,
I will say I didn't expect this talk to turn into an advertisement for OpenAI, but I see people saying they want to go play with it, and that's pretty exciting. I think that the talk really provoked a lot of different, very interesting questions and ideas in people. I've found myself during their talk, Clayton, sending off messages to other people that are not here, and just you know, trying to introduce them to this talks, because I think it's going to be fun when it's recorded and they can go and listen to it. And so if it's all right, I think what I'll do is I'll change over to sharing
sharing my screen
Okay.
and just repeat.
Oh, I meant to say, so I did stick a few references into the last slide. So if I may, I'd like to send you the slides in case anybody else wants to get them, including the references. Would that work?
That would be
Now
great.
that
yeah.
slide, you did put that slide up, right? For a while?
I
Just
I
very
probably did, but I
briefly.
don't know how legible it was.
Okay. all right.
Anyway, I'll send it to you.
Yeah, that's great. That's great. Well, we really appreciate all of this. I really find this to be one of the freshest talks in human-computer interaction I've heard in a long time. I really am looking forward to the publications you're going to make out of this, or is it a book? I don't know. I'd be happy, or I'm sure some of the people that brought up things tonight would be happy to think about it with you as that's.
Well, that would be great. As you can tell, I'm enthusiastic about this stuff. And I'll mention, I have published a couple of papers which overlap this a little bit. And those are, links to those are in the bibliography slide.
Okay, well, let's just let you, I'm going to stop sharing and you can put that slide up as the end.
Oh, okay. Okay.
End of this talk. And we'll leave that up for a little bit and we'll
Okay,
let
so
people
let's see here.
whoops, get back to their evenings after that.
So the challenge is whether I can find my presentation again.
Promises,
Which
huh?
tab is it? Right.
Yeah, exactly. Not that one. There we go. Okay, and then skip
View.
to the last slide. Should be the one with the references, I think.
I saw it slide by very fast. Isn't that
There
what
it is.
slides are supposed
Okay,
to
there
do?
it is. So
That's
let me get it bigger. Yeah.
All right, we'll leave that up for a moment. And Clayton, as I was telling people earlier, this is a talk series that we have only skipped 2 talks since 1989. 2 weeks I've been told, and one of them was at the beginning of the pandemic. What was the other one, Nancy?
It was the night of September 11th, 2001.
So that's quite a.
That was a Tuesday, and 4 people showed up at Park, as well as our program chair. And the program chair allowed us how we were not going to have a meeting that night.
Wow. Wow.
Mhm. But those are the only 2 times we've missed a
Well, as
monthly
I said,
meeting.
it's a real honor to be able to present to this audience. So thanks
And
again to all
I'm
of you.
glad we got you
Yeah,
before
we're glad
before you
got
retired or something horrible like that.
Well, maybe he has retired, but that means they're working better.
Yes,
I
even
mean,
better.
Where or do you have? You're doing this all by yourself. You often do. You don't have students involved all the time in your work. Is there students involved in this or not really?
Not really, but a couple of mentions. So one, Jason White, maybe some of you may know Jason. So Jason is an educational testing service, and and Jason, for people who don't know him, is actually a remarkable person. Someone who has a law degree and a PhD in philosophy. So my snippet of Robert Brandom is courtesy Jason, whose dissertation was on Brandom's work. And Jason and I have been talking about this stuff, and so he's been the inspiration for a lot of the explorations here, or the starting point of them. And also mention Patrick Basman. And actually, I don't know, has Andy DeSessa ever presented to Bay Chi?
Andy DeSessa, why not? That's a good idea.
Yeah, so
Not that I
actually,
know of.
it'd be worth sounding him out, because so people with long memories might know about the Boxer system that Andy developed, which is in the logo lineage. So a sort of a programming system for kids, which actually achieved quite some status back in the 80s and 90s, and then it dropped from view for complicated reasons, but it's been resurrected. And Antrik Basman, whom I mentioned, organized a workshop this spring announcing the reissue, the renewed availability of Boxer in a modern implementation, and also a wealth of historical information. So he tracked down many of the early users of Boxer and got their reminiscences, and then a talk about the the future of that. And actually, my first serious automatic programming venture with Codex was in that context. So I was interested in whether this technology could be used for sort of pedagogical computing, you know, where you're in a math class and you just want a program to do something or other. And, you know, to some extent, their answer is you can use it that way. And I think it raises interesting questions about what the point of such programming actually is. So is it just to have the programs, or is it to understand something about what's involved in writing them? And other things like that. Anyway, Atrig also has been.
No, I want to mention something as long as you're on this topic.
Yeah.
Which is that there's a history of logo that came out, that all of the people that wrote and worked with logo in the early days talk a lot about. This is the ACM proceedings, and it was on programming, and it was 2020. So it's a very interesting article called "The History of Logo."
Great. Yeah.
Well, so I guess I just don't want to keep people any longer than we need. We started with this number of people 5 minutes before the talk, and we doubled it during the talk, and now we're back down to 10 again. So, but as I said, I've sent out messages to some people that you and I respect to go and look at the video, and what we find is that the videos do get watched on YouTube. So, thank you everybody for joining, and I think with that we will close the session for the evening.
Thanks, Clayton.
Thanks, everybody.
Yes, good night.